Here's an example where we're going to triangulate a fire. The colonel spots a campfire at a bearing north 73 degrees east from his current position. Sarge, who is positioned 330 feet due east of the colonel, reckons the bearing to the fire to be north 33 degrees west from his current position. Determine the distance from the campfire to each man rounded to the nearest foot. Okay, so the hardest part of this one is drawing the picture and being clear on what a bearing is. Let's make sure we understand the bearing. So let me go over here real quick and just do a little bearing talk. So north, south, east, and west. If you're not clear on that, definitely put it on your notes for the next exam. So therefore, if I'm headed, let's say north 73 degrees east, what does that mean? That means north, but not straight north. Let me try that again. It's a little too much. Maybe there. 73 degrees to the east of north. That's north 73 degrees east. That direction right there would be north 73 degrees east. In other words, you start with north. When they say north 73 degrees east, you start with north, you start going straight up, but then you go 73 degrees to the east of north. That's the direction in which the colonel, so the colonel's here, and he spots the fire off in that direction. Whereas the Sarge, and I'll put this all in one big diagram in a minute. Next, let's do the Sarge. The Sarge, again, whoops, we get the north, south, east, and west. The Sarge spots the fire north 33 degrees west. So again, we start with north, but not pure north. 33 degrees to the west. So off in that direction, the Sarge spots the fire. From the Sarge's position, he spots the fire north and west to his upper left, and the colonel spots the fire to his upper right, north 73 degrees east. Do you see the deal? So in other words, when we put those two things together, see how bearings work? So this direction would be north 33 degrees west. And this one is north 73 east. Okay, so putting it all together then, we've got the colonel over here, called colonel. Colonel's over here, and he spots the fire. Let's see, the fire's going to be, let me put it about right there. He spots the fire like that. So this is the fire right here. In fact, probably should have moved stuff around. Anyway, it's all right. And then, there we go. There is the Sarge. And so remember how the angles work. So straight up is north. So it's good to put a little axis system right here. So a little axis system, north, south, east, west. And remember how this works. This angle here is 73 degrees, right? North, but 73 to the east. And then from the Sarge, same kind of thing. Put a little axis system here. And this angle is 33 degrees because it's north, west, southeast. So from the Sarge, it's north 33 degrees to the west. Do you see how that works? See what I'm doing there? I'm trying to make that a little bit better. Okay, and then here's the fire right up here. This is the fire. That's where they spot the fire. All right, it's just making some sense. So that's a diagram. Now, and how far apart are they? 330 feet. So come down here and go, this is 330, between the Sarge and the colonel. They're 330 feet apart, right? In fact, it says the Sarge is 330 feet due east, straight east. East is to the right. Sarge is 330 feet to the right. So there's our picture, and they want us to find the distance from each man to the fire. So let's call this C for colonel. It's how far the colonel is from the fire. We'll call this S for Sarge, how far the Sarge is from the fire. How are we going to find those? We don't have a right triangle. This is not a right triangle. So we're going to have to, we can't use SOHCAHTOA. Right? So we got to use law of sines. So, okay, so to do that, we got to find the angles in the triangle. We can start by finding the angles that are missing. Like, what's this angle here? So let me back up here, number 1. Missing angles. So what angles are missing? Well, this one right here and this one right here, right? And we can take 90 minus 73 to say that one must be, this one must be 17 degrees, right? Because these two together clearly have to make 90 degrees, don't they? See the 90 degrees right there? Because straight north and straight east make 90. Same thing here, straight north and straight west make 90. And so this has got to be 90 minus 33 for the other one. And that leaves what, 57 degrees? Yeah. This one's 57. And so now we can find the top angle. Step 2. Right? Let's find the top angle. Triangle has to hold 180. So the top angle must be 180 minus the other 2. Added up, 17 and 57. So the top angle must be, going to use my calculator here. Whoops. I'm getting 106. Top angle must be 106. So the fire angle up here must be 106 degrees. All right, so now we have all 3 angles, and now we can use law of sines because we have angle and side opposite, so we can set up with angle and side opposite, and then the same thing for this side, and we can get it. So now we're in business. So here we go. Law of sines, so that would be 330. Well, here, let me write law of sines so it's clear what we're doing. Law of sines. No, 330, right? 330. So these two right here, right? 330 over sine of 106, right? Law of sines is angle and sides opposite each other. I forget what that was. 106. Must equal, right? Law of sines says that if you take any angle and the side opposite, it's going to equal any other angle and the side opposite, the ratio, as long as you put the sine of those angles. That's the law of sines. So I can match those two up. So that's going to be C over sine 57. So, and so then I can solve that triangle. Solve for C there. So C times the sine of 57. No, what am I doing? I'm getting confused. C times the sine of 106 degrees is 330 times the sine of 57 degrees, right? And so now finish that, divide by the sine of 106 degrees. Like that, boom and boom. All right, so C equals, hit the buttons on your calculator. It's going to be all this stuff. Calculate it, 330 times the sine of 57 divided by the sine of 106. I'm getting 287.91. It says round to the nearest foot, so we'll just say 288 feet. So the kernel's 288 feet from the fire. Rounded to the nearest foot. Right here, nearest foot. Rounded, okay. And now let's do the same thing for the Sarge. So for the Sarge, we're going to do law of sines again. Same. I'm going to go back to the same one. 106, the 330 over sine of 106, and then these two, right? That's what the law of sines says. Side over angle across from it. So there we go. Same kind of thing on step number 4 here. So I'm going to go law of sines. I'm going to go again 330 over the sine of 106 equals, and this time I'm going to go Sarge over, what's the angle across from Sarge here? Sarge and sine 17 degrees, right? He's across from a 17-degree angle. So again, we will cross multiply. So 330 times the sine of 17 degrees is Sarge times the sine of 106 degrees divided by the sine of 106 degrees. These cancel, and we'll use our calculator to find out how far the Sarge is from the fire. 330 times sine of 17 divided by sine of 106. I'm getting 100.37. We'll round that to 100 feet even. Sarge is 100 feet from the fire, so we'll put that answer in. Sarge is 100 feet. It makes sense. Sarge looks closer to the fire than Colonel, right? So how did we do that? We drew the diagram carefully using what the bearings mean. So if you're confused on that, you always want to draw an axis system. See how I drew an axis system whenever I did the bearing? And then I did north 33 west, or north 73 to the east from north. You have to start with what they say. They say north 73 east. You got to do north first and then go 73 east of that. Or north first here. This is north 33 west and then 33 to the west. And then I found the missing angles by subtracting from 90, found the top angle. Every triangle holds 180. Did law of sines to finish it up.